Today I'm talking about an architectural approach to the application of multi-agent systems in the context of flexible production. My name is Achim Wagner. I'm the deputy head of the DFKI Innovation Factory department and also the scientific director of the Smart Factory Kaiserslautern Technology Initiative. I will also present our approaches in this way. Kaiserslautern is located near Saarbrücken, about 60 kilometers in the east of Saarbrücken, and this is, so to say, the new location in the project. First of all, I will give an overview of the scenario for autonomous human-centered shared production, the vision of a multi-agent system for distributed control and AI integration, the design of Holonic system architectures, the concept for the integration of multi-agent system frameworks, method-based middleware, and IO Industry 4.0 standards. And finally, I will give some first results and the conclusion. Not working. Next one, please. Oh, no, it's working. So first of all, I'd like to describe the Smart Factory approach for production level 4, focusing the autonomous human-centered shared production. The scenario shows a number of production islands, so to say, and the production islands consist of a number of production modules and conveyor systems and operating technology. And additionally, we have some manual workstations which can be used for for post-processing of parts or for overcoming production losses, for example. The production islands are producing some components or sub-assemblies of a model truck, such a Lego bricks similar truck, and the subcomponents are transported between the islands using unmanned or driverless transport systems. And further, we have quality control and the delivery of the final products to the customers. The overall system is connected to the Gaia-X framework, and in this way we can enhance the production system with external partners, and we can include additional external production facilities and transfer offers for producing and so on. This is an example of such a production island. This is also shown on Hannover Fair. This is production island Java, which consists of a number of production modules and a conveyor system. The production modules have some functionalities for storage, for assembly, quality control, and data refueling. Furthermore, they're providing some plug-and-produce facilities in order to have flexible interchange of modules. In the same way as we have a modular hardware in the system, we have also some modular software system, which will be developed in the framework of the European project Mass for AI, which is also included. We have partners from Saarbrücken and from Kaiserslautern in this project. And the idea is that we distribute software components on several levels, on layers of the system. For example, we have some control components on the modules. These control components are have some skills which can be provided to the system, and these skills are integrated into software agents which can be combined in a flexible way. So we can autonomously control the specific modules, and we can also integrate additional capabilities for enhancing the system with artificial intelligence software, for example, for cognitive support or for predictive maintenance, monitoring, reconfiguration, and so on the module level or on the factory level for planning and decision making, for example. Additionally, we can also connect other resources on the cloud over specific cloud connectors, for example, for using high performance or AI on demand capabilities. The challenge now is also to provide such a system to the industry in order to have also a system which can be easily implemented in the existing production lines. And therefore, we are using Industry 4.0 standards. For example, we are based on the RAMI reference architecture and also on the asset administration shell. And this enables us to have more interoperability between the agents and the components. This shows the Holonic structure of our approach. That means we have some specific agents which have some functionality. This is this orange blocks. And we have the interaction between the agents. And finally, we need also some methods to organize these agents. This is the coalition agent in this case. And all these agents are integrated in one framework. This is the Holonic multi-agent system structure. And we need also some functionalities for deploying these agents and to parameterize the agent on the one hand. And we need also some communication between the agents. And the communication within some holon, that's in some block, is done by some specific interaction protocol, such as Kafka. And we have also interaction between different levels of holons. This has been done by standards such as BASIS or OpenCUA as a middleware for organizing this communication. Yes, and what you see is also some agent patterns. The agent patterns are required in order to have some generic agents which can be reused in specific applications. Yes, according to this approach, we use the asset administration shell as a basic structure. And basically, each asset, this is say some functional component, is described by an information model which is included in the AAS, in the asset administration shell. In this way, we can define 3 types of holons. One type is on the left side aggregates pure software agents. The agents are described internally, and we have some aggregation of this agent in this holon, which is described by the AAS. Then the second one in the middle, this is the conventional component. This can be used in the Holonic structure in a way that we have an additional AAS on top of it, and we can also combine traditional, say, hardware assets and software assets in some way on the right side. The idea now is also to encapsulate the skills of the machines in a way that we can integrate it into the holons. This is shown here. One assembly skill, for example, can be decomposed into sub-skills such as Cartesian robot movements, which can be further decomposed into single-axis skills, for example. Then we can add additional skills such as gripping or quality inspection with cameras. This approach is shown here again. On the lower side, you see the hardware. The hardware is abstracted by atomic skills, such as axis movement, which can be combined into composite skills on the higher levels or on the top level. We can also integrate pure software skills, such as machine learning-based skills on the right side. In this way, we can combine easily control functionality and functionality for data analysis. How can I start it? Now, yeah. This is the example of a skill-based assembly. This is one module for assembly. You see the Cartesian robot with a gripper, and there are some skills provided by the system for moving parts, say pick and place, and for assembly, and also for say interacting with the shutting with the transport system. That means the modules can call the shuttles if they need it. The advantage of this approach is that the programmer or the application engineer does not need to program the single trajectories, but he can access to the skills and just you have to to get the parameters to the skills. And that's, in this way, that is much easier and much less effort to program such robots. Okay, this is the example. And I'd like to conclude. I propose the concept for controlling distributed production networks as a whole with multi-agent system. The basic idea behind is to use industrial standards in order to allow or to enable interoperability between software and hardware functionality. Then I showed the integration of software functionality and AI agents. This is also possible. And we have also some first implementation of this system. In future, we will work mainly on the patterns for specific agent types, which are very common in industry, in order to make it available and in order to have reusable components in the future. And secondly, we will work on the integration into several manufacturing systems, and this may be also possible to use it for interacting between the locations of Saarbrücken, Kaiserslautern, and Prague, and Brno, for example, and the others. And this would be, say, a nice development for the future, and I hope we can do that together. Thank you.